Good evening, everyone. So, welcome to the Mechanical Unit Operation course discussion. Today, we will discuss about the content of week 8 week course, that is on filtration. Okay, so we will go to the basic theoretical fundamental learnings of the filtration, and we will discuss about what are the formulas and rules are applying, and that's it. We will again also discuss about the filtration equipment. Now I am sharing my screen. Okay. I hope you will see my screen. Okay, so this is the today's talk regarding filtration, and basically in this particular wicket assignment problems, you can see there is no any examples problems are there. So deliberately I didn't include any of the example in the today's discussion. I'm just discussing about the main important things, main theoretical parts, principles, and formulas, or some important part which is required for you to solve the problems. Okay, so I am just starting the presentation now. Okay, so this wicket discussion is mainly, you can say, the introduction of filtration and the basic different methodology of filtration and what the principle behind it, and subsequent lectures maybe discuss more about the some specific practical application and some specific filtration process. So this week detail consists 4 lectures. One is filtration, then 2 on the principles, and the last lecture is on the filtration equipment. I only just took some part from the filtration equipment because most of the questions are on the all other 3 lectures. So this is the outline of the today's discussion. We will start with the filtration. What is filtration? What is the mechanism of filtration? Then the major discussion is on cake filters. Then what are the properties and selection criteria for the filter media, and what is the filter aid? Then what is the principles of cake filtration? And one more well-known filtration is the centrifugal filtration. What is the principles behind that centrifugal filtration, types and selection of equipment. Okay, so first thing first, what is the filtration? So filtration is the separation of solid from a suspension by passing it through a porous filtering medium, or you can also say consider it as a septum on which solids are deposited, whereas fluid pass through. So whenever we have fluid and solid part in this any kind of equipment or any kind of process, if you want to separate it out, then we have to use the filtration. Solid will remain up and we will get liquid out of it. So it is the same thing. It is a separation from solid from a suspension, because it has a solid in fluid, by passing it through the porous filtering medium. So okay, so filtering medium, it is porous, or it is also known as a septum, on which solids are deposited. Solid can get deposited on it and fluid can easily passes through. It is also known as the separation process of solid particles from liquid through a solid support or filter medium. So it is a separation of solid from liquid with the help of solid medium. It's a simple definition. Now, mechanism of filtration, there are many important point you need to talk, you need to remember. There are many important word you came across when you discuss for filtration. One is the slurry. So slurry in the filtration operation is known, it is nothing but the suspension of solid and liquid which that needs to be filtered. Filter medium, which is a medium which we use to filter the solid out of the liquid, or you can say the septum or filter medium, which is a solid medium of in which filtration process take place. Filter cake. So when accumulation of solid on filter medium will take place, it is known as a filter cake. And filtrate, which is the clear liquid which is passed through the filter medium and which we collect at in the receptor. So it is known as a filtrate. Now, in order to, if you want successful and efficient filtration process, then you need to talk about the different modified pre-treatment of the suspension, or you can say filter media. So in that, in filter media, in order to efficient filtration process, we require some pre-treatment which includes heating, recrystallizing, and adding a filter head. Filter head addition which will increase or which will support the filtration operation. Another two methods are heating. So after filtration, if cake is deposited, then heating is important. Recrystallizing, after the solid, if you want to recrystallize the material from the liquid, then also you can use this recrystallizing method for the efficient separation of the solid from liquid. Then if you talk about the different types of filters, then many types of filter has been developed, because every filtration operation has their own specific operation and specific application. So many types of filters developed due to in order to achieve the particular operation, a particular application. That's why different types of material, for filtering the different types of material, different types of filtration operation can be taken place. And at the same time, they are also widely differing from the process condition and operating parameter of different processes that we need to take care of it. Another main important thing is like that fluid flows through a filter medium because of pressure differences across the medium. So fluid cannot easily pass through the filtration medium or filter medium. We need to provide some amount of driving force, a major driving force which we are providing in the filtration operation, which is based on the differential pressure or pressure difference along the two sides, across the sides. Then operating with atmospheric pressure on upstream side of the filter medium, and that is another classification which is known as operating with atmospheric pressure on upstream side also, and a vacuum on downstream side of medium. So we can do one thing in the upstream side, we can provide the pressure in another way. Other than this pressure, we are providing the vacuum here, so it can also work to add the filtration process. Now as you can see here, three different major forces we are using as a driving force in the filtration operation. One is a vacuum. If we provided the vacuum, then filtration process can be easily taking place. Another is a pressure. If we provide the pressure from upward side or upstream side, then filtration process can be smoothly taking place. And the another is centrifugal. We can use the centrifugal operation. We will provide the centrifugation to our solid and liquid suspension slurry, and at the end you will get the liquid is you are getting out from the pure form, and solid get deposited in the filtration medium or filter medium. So these are mainly three kind of different forces which we can apply in this filtration operation. All this is required to generate the pressure difference in order to carry out the filtration. So higher pressure above atmospheric pressure may be developed by the force of gravity acting on a column of liquid, or by a pump, or by blower, or by centrifugal force. So this higher pressure, which is obviously more than atmospheric pressure, may be developed by using various force. One is a force of gravity on a column of liquid, or we can use some mechanical aids like pump, blower, or centrifugal force by using some mechanical equipment, and then we will get good high pressure difference across the medium. Now if we talk about the gravity filters, which is as name suggests, it is used the gravity as a driving force, and which can be used for the coarse grain particles to or the separation for the coarse particle from the suspension. So gravity filters can be no finer than a coarse grain or a bed of coarse particle like sand. So whenever we are using gravity filter, then there will be some limitations that it cannot be finer than the coarse grain or a bed of coarse particles like sand. It is not you are not getting the particle size lower than the sand particles. So you have to keep in mind that this gravity filter is used for the coarse filtration operation. That's why they are using in the industrial application, but due to this coarse uh, particle size, they are restricted in some of the use, like draining of liquor from very coarse crystals, clarification of the potable water, and treatment of wastewater. So this wastewater treatment, if you know, then gravity filters or gravity sedimentation tanks are there always in the one part of the wastewater treatment or effluent treatment part, where you treat the effluent from the different industries. So that's why that is a major use of gravity filters. Now if we talk about the industrial filters, which is used for the specific process and specific product to filter it out or to removal of solid from unwanted solid from the liquors, then basically there are three different types of filters or separators they are using, which can be used in the batch or the continuous way type, according to the applied force on filtration and according to the application. The one is a pressure filters, which is used high pressure difference, and which is used pressure to as you can say plate and frame filter, where we use the pressure to just filtering out the solid out of liquid. Another is the vacuum filters, where we use the vacuum force to for the filtration operation to be done. And the another is the centrifugal separators, where we use centrifugal force for the same purpose. Now, if you talk about the nature of the operation of filtration, then there will be two different filtration processes there. One is, you can say, the batch process or discontinuous filtration, and another is a continuous filtration. So the discontinuous filtration, during operating cycle, flow of fluid through the device is continuous. However, it is interrupted periodically to permit the discharging of accumulated solid. As you know, plate and film filter, it is in continuously we are providing the flow, continuously provide the flow of fluid, but it is interrupted multiple times in order to discharging the accumulated solid. So whenever we are doing the filtration operation, then there will be solid cake formation will be there on the filter media, or whenever you are providing the plate and frame operation, any kind of filter is there, and there is accumulation of solid will be there. It is only known as the caking of the filter media or cake formation on filter media. So we need to periodically remove that cake in order to efficient operation of the filtration on filter media. Then there is another way, which is another way of filtration, which is a continuous filtration. In this discharge of both solids and fluid is uninterrupted as long as equipment is in operation. So whenever we are performing an operation, this solid material as well as the fluid will continuously discharge, and it will remove from the solid filter media, and that is the arrangement of the filtration equipment is like that. It can operate continuously without any interruptions. So that comes into the continuous filter. Now if we talk about the filtration mechanism, so this is basically we just discussed some basic principles, which are the driving force and which kind of the different, according to the driving force and application, which kind of filtration process available, and the nature of the operations, like continuous operation, batch wise operation. Now if we want to understand how it is taking place, then we have to go to the filtration mechanism in detail. So there are basically three different mechanisms. If you want to go for the classification of the filtration according to these three different mechanisms, then you can consider that one is a cake filters, another is a clarifying filters, and the last one is a cross flow filters. These three are the very major class of filters available, and inside it there are many different types of filtration equipment which are using into the industry. for the many different kind of applications. Now we will start with the cake filters. So cake filters, as name suggests, this is a filter on which cake of the solid deposit can be occur after some amount of time, in during the operation the solid can be deposited on the filter media as the cake. So this will be used as a large amount of solid as a cake of crystal sludge are separated by cake filters. So when we are using the cake filters, so our main goal is to separate out a large amount of solid from our what you can say suspension of liquid and solid. So if you want to separate out a large amount of solid and in the form of cake of crystals or sludge, then you can use the cake filters. So as you can see that it is a filter medium. This is a suspension. This is a cake filter. When we are providing the pressure from above it, you will get the filtrate from downside, and you can see many solid particles are there. Before filtration operation going on, they are not very near to each other. They are apart from each other. But after starting providing the pressure, and it will generate the pressure difference, like here is a P2 and here is a P1. Then you can see the solid particles have come near to each other and they are forming the cake after some times. As you can see, again it is getting pressed. Filtrate can be, you will get the clear liquid which is known as a filtrate, and after again providing the pressure, you can see that filters solid liquid suspension is converted into the filter cake, cake of crystal and filtrate. Here as you can see, P1 is always greater than P2, and that's why the difference of pressure in filtration operation is can be considered is going to P equal to P1 minus P2. And this is the filter cake look like. So this is a very basic picture, but as you can see, this is a filter medium, and after some amount of time all the solid particles are accumulated onto this medium, and it is known as a filter cake. So they include provisions for washing cake and removing some of the liquid from solid before discharge. So this cake filters also have provisions for washing of cake and removing the liquid from the solid before discharging it. So they are in sort of flexible filtration equipment or filters. Now another filter major class of the filtration equipment is clarifying filters. Here you can see that they can able to remove amounts of solids to produce clean gas or sparkling clear liquids such as the beverages. So it is using to generate the clean gas or the sparkling clear liquid such as beverages. When we are using the beverages, then this is the one important class of filter which we are using. Particles are trapped inside the filter medium on its external surface. As you can see, this is a clarifying filter, or sometimes it is also known as a depth filter. So there are many channels are there in which our fluid is flowing. Our suspension is pouring on this whole, as you can say, whole section. Out of which there are many small channels are there where your fluid can easily pass through, and fluid or liquid or gas can be easily passed through, and whatever amount of solid material there, the solid material is not able to pass through hole because of the structure of this filter medium, which is not uniform at all. So that's why solid can be trapped inside these channels. So that's why it is you can see that in the clarifying filters that it is mentioned that particles are trapped inside the filter medium on its external surface. On the external surface, they are not going inside. Pores of filter medium are much larger in diameter than particles to be removed like the screens. So here you can see that pores of the filtration medium is larger than the particle size. When we are talking about the screens, then in screens it is a particle size is totally exact or perfectly matched with our screen size, but here it is not the case, that filter medium has larger diameter channels than the particle size. Now the third and the last major kind of filter is known as a cross flow filters. As name suggests, there is some cross flow is going on in this kind of filtration operation. So once you start with the feed suspension, this is the membrane. Generally membrane kind of filtration is using by this method. Here you use your suspension at in the flowing motion at high pressure, or at high velocity rather than pressure across this filter medium with cross flow filters. Then thin layer of the solid, as you can see, may form the surface of medium, but high liquid velocity do not allow it to build up. Here you can see that small solid particles are forming the surface, or are forming the medium, but measure of the solid particles, due to this high velocity, they are not able to sustain here, or they are not able to stable here, and they will go with the with our final suspension, and then you will get the solid particles is not present here majorly, and they are not forming the cake. But at the same time, as it is a membrane structure, so our liquid or filtrate is passing through it, and we will get the pure filtrate in the bottom of the filters. So as you can see here, filtration motion is like this, or fluid flow in the filter for filtration is like in this direction, and the filtrate you will get at the perpendicular direction. So that's why it is known as a cross flow filters. Now ceramic metal or polymer membrane can be used with small pores enough to exclude most of the suspension particles which are using as a filter medium. So basically membrane, if you talk about the membranes, a major part of the membrane can be come from the metal or polymer membrane. But although there are very different kind of membranes are there, so they are using for this particular cross flow filters mechanism. But you have to make sure that their pore size is small enough to exclude most of the suspended particle. There should be no suspended particle come with liquid. So portion of liquid passes through the medium as a clear filter, leaving a more concentrated suspension as a retentate. So at the end, if you find any liquid portion which can be passes through as a clear filter, and it has at the end concentrated suspension, which is known as a retentate. As you can see in the fish filtering process, the feed is going through from this, and whatever the liquid is taking, a liquid you get, it is permeate. It is known as a permeate, a clean liquid, and here you can see it is a retentate. It is a more concentrated suspension. So we just see the video and understand. So as feed is coming from here, the permeate is a pure liquid which you found there, and then after some time, if you are providing the back pulsing, then the cleaning of the filter medium will take place. Okay, so these are, we already discussed about the different basic filtration mechanism, which is nothing but the cake filtration, or clarifying filtration, and cross flow filtration. So clarifying filtration, as we discussed, it is also known as a deep bed filtration. Cross flow filtration is there. Blocking filtration is used when we want to just, it is similar to the cake filtration only, but when we have less amount of solid particles sustained in our suspension, then it is consists of a suspension, and we are using the blocking filtration. They are basically responsible for blocking the path of the concentrated liquid. So as you can see, sorry, as you can see in the cake filtration, if you draw the curve P versus V, then it is a very linear. As after increasing the velocity, the pressure is always again also increasing, and why? Because velocity increment will give much more higher cake formation here, and as high cake formation provide a higher pressure, so higher pressure resistance. So that's why you can see P versus V graph of cake filtration is always linear. If you talk about the blocking filtration, then blocking filtration has a less solid into the suspension, so that's why in the first end you are not getting the whole linear curve, but after some amount of time, as you can see, it's exponentially increases once the velocity of the filtration process is increasing. Third one is the, as we discussed, the clarifying filtration, which is also known as a deep feed filtration. So deep bed filtration. So in the deep bed filtration, there are many channels are there where your filter you can keep it, and once it is required, you can give it to the world back. But the main thing is that when deep bed filtration is taking place, if you plot this concentration ratio versus velocity, then as velocity increases, it is hysteresis kind of structure, as it in the first end, with increasing the velocity, the concentration fraction is not increased much, or more fraction you can consider. But for high velocity, it is oppositely increasing exponential to the concentration, and this is a cross flow filtration, as your product is you are getting here, and this is your cake this is your liquid or fluid permeate which you will get here with solid. This is your permeate, actually this is a solid product you will get at the end of the filtration. But if you are plotting the graph, the time flow rate versus time and thickness of cake versus time, then as you can see that this kind of graph always we need to use for the cross flow filtration, where thickness of the cake versus time is slightly increasing, and then after some amount of time it is properly maintained the thickness, and the same as a flow rate. Flow start with high flow rate, then it is decreasing, and then it is a constant level by some particular flow rate. So now there are some questions in the your assignment problems which is related to the filter media and filtering aid, and how can we have a control on it, and how can we select the filter media. So this is the some part where this is the some discussion which we are discussing the filter media, and alongside the different other important materials which we are using in our filtration. So if you talk about the filter media, then in industrial applications, a common filter medium is always canvas. If you talk about the plate and frame filter, plate and frame filter, it is a very important filter in the industry. It always consists the canvas cloth as a filtering medium or filter medium. But it is not like that. You can use the wooden cloth, metal cloth, glass cloth, or paper cloth, which can use as a filter media for the corrosive liquid. When you are dealing with the corrosive liquid, so not only this canvas cloth can be helped, so you need to go for a wooden cloth, or you can use the metal as a cloth, or glass as a cloth, or paper cloth as a free filter media for corrosive liquids. Now if we talk about the synthetic filter media, then synthetic fabrics such as nylon, polypropylene, and various polyesters can be also be used as the chemically resistance filters. Filtrate may first come through as a turbid or cloudy, and then gradually clear filtrate obtained, then cloudy filtrate is written. The clear filter is obtained. It started with the turbid or cloudy filter, and at some gradually you will get a clear filtrate, and there to whatever the cloudy or turbid filtrate there, you need to again send back it to the for the refiltration. So in the starting of the filtration, you have to take care of this fact. Now categories of the different material which can be used as a filter media. We'll start with the woven material. So woven material can be used as a filter medium. Perforated steel sheet metal. Perforated metal sheet has perforations in it, or you can say holes in it, that can be used as a sheet metal. that can be used as a filter media. Then bed of granular solid built upon supporting medium. If you have bed of granular solid which also built upon some supporting medium, then you can use this as a filter media. Prefabricated porous solid units and membrane filter media. Now, what is the requirement, or how do we select the filter media, or it is also known as a septum? Okay, so what are the basic requirement? The most important requirement is economical. It needs to be economical in nature. Then it needs to not to be stuck very easily. It can be easily clean, washable. So these are the basic requirement. From just knowing the filtration topic, we can imagine. Now we will see what are the requirements is there for septum as well as, or you can say, filter media. So first thing is, it should be written solid to be filtered and provide acceptable clean filter rate. It should not plug or blind. Obviously, if your filter media should plug or it should blind, then it is very difficult for the septum to operate the septum for a longer period of time, or if you want to use it for the continuous process, then it is very difficult. So it should be chemically resistant also. You should not use a material which will react with your chemical which is suspension, which consists some chemical. If your septum material is react with that, then your septum will be damaged and your final product quality may be hampered. And it needs to be strong enough physically to withstand the process condition. If you are providing the high pressure process condition, generally in every filtration process we provide a high pressure, so it should be high pressure or the vacuum. It should be physically withstand that process condition, and at the same time it should permit cake form to discharge cleanly and completely. It should not like every filter can permit the cake formation, but it should be discharged cleanly and completely. It should not prohibitively expensive. Obviously expense, it's a major important role. Economic as playing a major important role in the filtration operation. Now, if you go for the basic some requirement, then it should be capable of delivering a such clear filtrate at a suitable production. So obviously your filtrate should be the clear. If you are not getting a clear filtrate, you are getting the turbid filtrate, which then there will be no use of using your filtration equipment. It must have sufficient mechanical strength. Obviously we discuss here it it should be inert. We already discussed it is not chemically resistant. It should be chemical resistant. It is not easily react with the chemical. It can retain the solid without plugging at the start of the filtration. At the start of the filtration, if it is plugging, solid is plugging, then there will be easy cake formation is there, and you will not get any kind of clear liquid out of your filtration operation. It should not absorb dissolved material. Is there any dissolved material is there in your suspension? It should not absorb. Sterile filtration imposes a special recrupencies. The pore size must not exceed the dimension of bacterial spores. So sterile filtration will require whenever we are using for some specific application related to microbiology, or you can say biotechnology, but it has a special requirement in which the pore size must not exceed the dimension of the bacteria or spores. So your filter media has a pore size equivalent to the whatever the thing which we are going to use it for, dimension of bacteria or spores. If we talk about the filter aids, then there is now we will discuss about the filter aids. So what is a filter aids? They are very fine or slimy solid, often form a dense impermeable cake that can quickly plug any filter medium that is fine enough to retain such fines. So filter aids are as its name suggests, it's the aided material which we are using for increasing the filtration operation. In that, it is a fine and slimy solid which we are using for the impermeable cake that can quickly plug any filter medium that is fine enough to retain such fines. Okay, so our filter medium should be fine enough that it can enough to retain such fines. Then that filter aid can quickly plug to it, and then it will enhance the filtration operation. Now feasible filtration of such solid require the porosity of cake be increased to permit passage of liquor at a reasonable rate. Okay, so this kind of aid will be helpful into the feasible filtration process which can in which solid required porosity of can be increased to permit the passage of the liquor. So these are the useful characteristics which we can get after adding the filter aids. Now it can be accomplished by adding the filter aid to slurry before start of the filtration. So filter aid should be inert. This is one criteria. So you have to keep in your mind, and it can be okay. So before start of the filtration, it can be accomplished by adding a filter head. Obviously, we have to add the filter head before starting the operation only. And if you want some example of filter head, then diatomaceous silica, perlite, purified wood cellulose, or any other inert porous solid which can enhance the filtration rate. So these are some examples which can enhance the filtration rate. Now, if you are using this filter head, then subsequently filter head may be separated from the filter cake by dissolving the solid or by burning out the filter head. So we can do one more thing. If you want to remove a filter head, so it should be easily separated off from our filter cake by dissolving it with some solvent. Or we can do one thing, if it is not required or for our any other process, then we can burning out the filter head and we get the pure solid. If the solids have no value, if our final solid has no economical advantage to our process, then we can discard our solid with filter head, because filter head anyway it is a cheap product. But if you cheap material only. But if you want to use the solids you have required a pure solid, then for it easily dissolve by dissolving solid, or you can burn it out, filter, and you can get. So these are the two ways to getting your pure solid out again. Now if you want to handle the filter aids, then they need to, if you are using the filter aids, then handling the filter aids require some kind of expertise. So how can you handle the filter aid? First thing is that filter aid may be used in either or both two ways. There are basically two ways how we are using the filter aid. One is we can coat the filter aid to the filter media, which is known as a pre-coating technique. In the pre-coating technique, forming a pre-coat over the filter medium by filtering a suspension of the filter aid. So whatever the filter suspension we have, we will filter it out, and that filtering out filtered suspension make a coatation or coat in or above the filter medium. Another is a body mix technique. So a small proportion of the filter aid is added to the slurry to be filtered. So okay, we will add the small proportion of filter aid 0.1% to 0.5%, and we add it to the slurry which needs to be filtered, and this slurry recirculated through the filter until a clear filtrate is obtained. A filtration and process proceed to completion. So in the body mix, you have to add the small portion of the filter aid, and then you need to wait. Again you have to filter the slurry, and again you have to recirculate again and again unless you will get a clear filter at the end. These are the two ways how to use the filter aid into the filter medium on filter medium. Then different flow rates can be achieved depending on the grade of aid. So if your quality or properties of your aid, they can be you achieve a different kind of flow rate. In the raw flow rate, if you want to achieve the raw flow rate, then you have to go for the filter rate which are fine grade filter in the size. So they are generally used for the clarity of the liquid. Another flow is a fast flow where we are using the filter rate, which is a coarse grade filter rates, and this can acceptable filter rate. So example of filter rate: diatomite, Kesselgore. Kesselgore is a very important filter rate which is used in the many of our processes. It is obtained from the natural siliceous deposit. Perlite is an aluminum silicate or cellulose. Asbestos, charcoal, teak, pentomite, fuller's earth, etc. Now, principles of cake filtration. We are discussing about the second part, which is nothing but the principles of the cake filtration. Now, we already in the last week discussion we discussed about the different Argan equation and Kozny Karman equation in for the flow pass solid materials, solid bodies, or flow pass, you can say that fluid flow through packed medium or fluid flow to the fluidized bed. So in the cake filtration is a similar kind of situation occurs when we using the suspension solid make the uh, packing on the filter media, as you can consider like this. And after that, if we are providing the liquid suspension from above, then here you can use that same kind of equations which we are using. So principles are analogous to the case of flow through the porous media or packed media or fixed beds, which resistance to flow is independent of time. In the cake filtration, resistance to flow increases with time as a filter medium becomes clogged or filter cake builds up. So you can use the Argan equation, and you should modify it according to your use. So here in the cake filtration, resistance of this cake filtration will flow increase with time, increase with the filter medium also with time as a filter medium resistance on filter medium will increase with time as the solid material will come and clog on the surface of the filter medium. Now, important parameter of interest in the cake filtration are flow rate through the filter. First, we need to discuss or we need to consider the flow rate, and another thing that needs to be considered is the pressure drop. So, in order to find the better equation to represent our cake filtration process, then we have to represent in terms of the flow rate and pressure drop. As the time of filtration increases gradually, either flow rate decreases, obviously due to resistance increases, the flow rate will decrease and pressure drop also increases. Flow rate can be decreases and pressure drop increases. You should have to take care of all these small different principles and different methodology of the cake filtration, as it is directly come in your assignment problem sometime. Now, in constant filtration, constant pressure filtration, the pressure drop is held constant and the flow rate allowed to fall with time. Okay, so this is if we discuss about the filtration, this is a filter medium. Okay, so this is, as you can see, if you want to talk about the constant pressure filtration, if you are providing the pressure constant only, so after some times, as you can see, your flow rate should decrease or fall with the time. So that is a one way of filtration which is known as a constant pressure filtration. And another filtration, it is known as a constant rate filtration, in which we have to use we just approach in our approach we just provide the constant flow rate, then pressure drop is progressively increase. Obviously if we provide a constant flow rate over here, then pressure drop is increasing with time to give constant filtration rate. And this is a very rare application in the industries, which is not much used due to high economics. In cake filtration, the liquid passes through the two resistance in series: resistance because of the formation of cake and resistance of filter medium. Okay, so one resistance due to this cake formation and another resistance due to this filter medium. Now, filter medium resistance is normally important only during the early stages of cake filtration. As the filtration is started, at that time only we will bother about this filter medium resistance. But if we talk about the after some times, the cake resistance is in the start of cake resistance is 0, but after some time it increases with time as a filtration process, and after some time only the cake resistance is important and not filter medium resistance. If cake is washed after it is filtered, both resistance are constant during the washing period. If you are providing the washing of the cake, then you have to take care of the thing that both the resistance are constant, and that of the filter medium is usually negligible. Now, pressure drop in cake filtration. If you are providing the overall pressure drop, if you want to check it in the cake filtration, this is a filter medium and this is a cake. So overall pressure drop is the sum of the pressure drop over medium as well as cake. So as you can see, PA is the inlet pressure, PB is the outlet pressure, and P prime is the pressure at boundary between cake and medium. then delta P is equal to PA minus PB, then delta PC plus delta PM. Delta PC and delta PM are the pressure drop over the cake and medium. So this is how can you generally use the overall pressure drop, you find the overall pressure drop for this cake filtration. Now if you want to derive it by using Ergun equations, then or different equations which you already discussed, then you need to consider a thin layer. Okay, so this is a thin layer of thickness dl lying in the cake at a distance L from the filter medium, and corresponding pressure at this layer is P, which is mentioned, and then you have to find the pressure drop in this layer, and then you need to integrate over the whole cake. So this layer consists of thin bed of solid particle through which filtrate is flowing. In this filter bed, the velocity is sufficiently low. Okay, so the velocity value is sufficiently low, so we have to ensure the laminar flow, and after that we will use the laminar flow process. So now if you want to derive the equation for the pressure drop, as we are using the low laminar process, laminar flow is low and low Reynolds number, then we can go for the Koznik-Ullmann equation, Koznik-Ullmann equation for the low Reynolds number. So this is the equation which is in the simplest form, and this constant will be converted into the K1. So here I am not going for the much detail of the derivation and all, as you don't have any problem find in your assignment section, but I am just taking care of all the major point of this filtration chapter. That's why I am just putting the equation which is important to understand the pressure drop calculation in order to derive it for the different kind of cake filters and constant pressure filters and constant rate filters. So here as you can say that dP by dl is the pressure gradient at thickness L, mu is the viscosity of filtrate obviously, u is the linear velocity of the filtrate, epsilon is the porosity of the cake, sp is the surface area of the single particle, and vp is the volume of a single particle. So you can use this whole equation, and instead of dl you can convert it into the dm by converting into volume is equal to density into mass. Now there are two different types of cakes will form in the cake filtration. One is an incompressible cake which is not compressible, another which is not, we can't compress it, another is a compressible cake. So if you talk about the incompressible cake, then you have to use the same equation, and then you need to do the integration in the limit of P prime to PA, as we are discussing about the same P prime and PA, the whole process. P prime is here, it's a P in our filter medium figure which we discussed. So it's nothing but the same 0 to MC for the other side, and we'll get the delta PC value like this. Now filter cake of this type are called incompressible. If you are using the filter media in which filter cake or suspension material is forming the filter cake, which we can solve it out by using this equation, it is known as the incompressible filter cake. And here you can see that resistance is independent of the pressure drop delta P and position L. So if we just discuss about the resistance, then it is much different than pressure drop delta P and position. Pressure drop delta P, so there is a difference in the position. So the alpha is known as a specific cake resistance, as we discussed about the cake resistance. So you can see alpha is equal to delta PC A upon mu u MC. This is the equation, and it is nothing but the same this phenomena presented into the another form. Now if we talk about the compressible cake, in this the compressible cake, the name suggests, it is made out of the industrial slurries which has agglomerates or flocks consisting of loose assemblies which can easily compress. and which has a very small particle. So loose assembles are a which consists of small particle, and it has a resistance of such cakes depends on the properties of flux rather than on geometry of individual particles. So we don't have to bother about the geometry, but we have to bother about the properties of the flux. So according to the properties, it can be compressed and how much it cannot withstand the pressure and all. We need to discuss, we need to understand, and then we can go for the uh, process design of this compressible cake formation filtration. Now, resistance of such a cake is sensitive to method using in preparing slurry and to age and temperature of material. And such filtration cake is called as a compressible filter cake. So, such kind of cake has a resistance which is very sensitive, obviously, because resistance is a function of pressure. So in such compressible cake, a specific resistance varies this distance from the septum also. Here, if it is at the distance with the different distance with septum, it is varies. Because cake nearest to the septum is subject to the greatest compressive force, it can compress vary at a high magnitude and has the lowest void fraction. This makes the pressure gradient not linear. And here, if you want to go for the value of alpha, which is a cake resistance, then alpha is equal to delta PCA upon mu u mc. A similar kind of equation we are using, but here it is much more important to understand the distance as well as pressure. Now empirical equation for cake resistance. So as we discussed about the alpha, which is a cake resistance. Now if you want to find it, then there is a one way to find it, which has the equation of empirical form where you can find the alpha. So by conducting the constant pressure experiment at a various delta p, the variation of alpha with delta p can be found easily. If alpha is independent of delta p, the cake is called to be incompressible. Obviously, if alpha is dependent, then it's a compressible. In general, alpha increases with delta p as most cakes are compressible at least to some extent. Obviously, when you are using the suspension, then their solid particles have this physical properties like that it can compress at least to some extent. So most of the times we are getting this compressible cake filtration process. In that, if you want to find the value of alpha for the highly compressible cakes, alpha increases rapidly with delta p. So you can use this equation alpha equal to alpha naught and delta p raised to s, where delta p and alpha naught and s both are the empirical constants. It is vary depending on the equations. And if you want to talk about the s, then it is known as the compressibility coefficient of the cake. So if s is equal to 0, then it is an incompressible cake. If s greater than 0, then it is a compressible cake. Usually varies between 0.2 and 0.8. So if our value of s is greater than 0, then it is a compressible cake. Now principles of centrifugal filtration. Now there is another way of filtration which we discussed, which is not the cake filtration or pressure filtration, which is based on the centrifugal filtration. So we will discuss about the principles of the same. So it is a basic constant pressure filtration theory, can be modified if you want to apply it for the centrifugal filtration. So yes, definitely constant pressure filtration theory can be useful as in the centrifugal motion, centrifugal force can be a part of the pressure as into area, and then this theory can apply after the cake has been deposited during the flow of clean filtrate or fresh liquid through the cake. So this can be applied. This is the basic principles of centrifugal filtration. But for applying this kind of constant pressure filtration theory, you need to take some assumption in centrifugal filtration. The one assumption is effects of gravity and of changes in kinetic energy of liquids are neglected. You have to you are not considering the gravity effects and change in kinetic energy of liquid. Then pressure drops from the centrifugal action equals the drag of the liquid flowing through the cake. So your pressure drop value from the centrifugal, it is equals to the drag of the liquid. Cake is completely filled with liquid. Your cake should be completely filled with liquid. Flow of liquid is laminar. Resistance of the filter medium is constant. Cake is nearly incompressible. That is, every specific cake resistance can be used as a constant. These are some assumptions you need to take care when you use the constant pressure filtration theory for the centrifugal filtration. Now, as you can see, in order to derive the equation, this is a same centrifugal filtration. This is a one side of the centrifugal. It should be same in the other side, and this is a central axis from on which start rotating, and due to this centrifugal force, liquid and cake both go inside, go to this side. Then due to some, what you can say, because of the presence of filter medium, the cake will be not coming in the outside, and then liquid will be there. Liquid will easily come through the filter medium, and as you can see, this is Ri, which is the Ri is nothing but the radius of the inner face of the cake. R1 is the radius of the inner surface of liquid, and then R2 is the radius of the basket, inside radius of basket. B is the height of the basket. Omega is angular velocity, because the centrifugal filtration, so it is rotating, and we need to consider the angular velocity on the radian per second. Q is the volumetric flow rate of liquid, and rho is the density of liquid. So at the end, this is the one equation which we will discuss in the subsequent lectures and in the next weeks, that this equation of centrifugal action will come from the delta P is equal to O omega square R2 square minus R1 square divided by 2. You can use this equation to find out the pressure drop in the centrifugal filtration process. Now, types of the filtration equipment. If you just discuss about the various types of filtration equipment, then there are some filtration equipment are very much famous. One is a plate and flame filters, which is used largely into industrial operation. Leaf filters, which is more or same about the plate and flame filters. Then there is a rotary vacuum filters, which is used everywhere in order to find the pure quality of product. And the last one is a cross flow filtration. So rotary vacuum filtration and cross flow filtration both are the continuous operation. So these two filtration you can use for the continuous filtration operation, and other two are used for the batch operation. Now, how can you select the equipment for your process? So for selection of the filtration equipment, you need to always should understand what is your properties of filtrate and viscosity and density. According to that only, if it is very high viscous and very high dense material, then you can't use it into centrifugal. That's a different kind of basic properties you need to understand. Then what is the nature of your solid particle, their size, shape and size distribution and packing characteristics, and their reactivity with some kind of material construction. All this needs to understand in order to select the equipment. What is the solid to liquid ratio in your suspension? How much amount of solid is there? How much amount of liquid is there in your suspension? And it is need for recovery of the solid or liquid, or it is used for the just a separation purpose, and need for batch or continuous operation. That is also you need to take care of it. Now this is a small working video of the plate and frame filter press. So as you can see, it's a metal plate and frame filters. So it's different. This is a frame which you see, and now this is a plate. So one unit of plate and frame consists the filter medium. This is a filter medium plate, which you can see the how much compact. Okay, sorry, it's compact assembly is there. It's too much compact. Okay, so as you can see that filtered media suspension is going through it. The one you saw the plate, and this is the whole frame. One you saw the frame, and this is the whole plate and frame whole assembly using the two filtration. Everywhere filtration is there, filter medium is there. Now we will see the different. When you are applying for the washing, then there is a two different ways to applying using this. When you are applying for the washing, then there is one direction, and when you are applying for the operation, then there is another direction. I am not going into the much detail of the filtration equipment, because there are not any questions is there for the assignment. But if you want to learn, you can watch these kind of videos, and you can get to know very well, very easily, and in short you can understand that these are the very simple equipment, so there is no much complexity is there, so you can easily understand for yourself. Now if we talk about the centrifugal filter, then this is the centrifugal filter which is using for the oil filtration process. Okay, so this is how it looks like. Dirty oil first enters into the down, it is going upward, where pressure valve should be used for the some particular pressure. This is some oil operation in the process, but we just want to see the how the filtration process is going on. All go into chamber, total assembly, everything will be set. Now it start to rotate, so which will provide the centrifugal action to all oil. Inside it you can see so suspended particle needs to be removed further using vapor sleeve. Degree of oil contamination is indicated by the thickness of sludge. If you have much sludge, then the degree of oil contamination is much higher. Now this is a rotary vacuum filter. So rotary vacuum drum filter, nothing, your particle suspension is here, your drum is continuously rotate, and inside it is a structure of drum piping, as you can see, and there is a agitator and washing pipes. Agitator, it needs to be agitator liquid, and washing pipe will provide the washing. There is a scraper because the washing water will be there, cake formation will be there when you come from there, and then solid product will be removed by using the scrapers. As you can see, they are removing the small parts, so you can understand. So these are some industry video, but you can understand to how it is moving. So they show some agitator and some motor drive, how it is going. So these oscillations can use to remove the solid out of it. Now in this lecture, mainly most of the details is covered from the textbooks only. So you can consider the unit operation of chemical engineering from the McGraw-Hill, McEwan-Smith. It is the most important for this filtration operation. All the major details are in that only, and all other different books, if you want to use, you can use it. You can use them for your better understanding. So today like every time I quote Jagdish Chandra Bose here, and he mentioned that if there was been any success in my life, that was built on the unshakable foundation of failure. If there was been any success in my life, then that was built on the unshakable foundation of failure. So as this great quote suggested, if you want to go for your success in your life, then you have to be ready with lot amount of failures, and the failure makes you much more courageous, that you can go through your success easily. Now with this I want to stop sharing. So at the end, I would like to thank you everyone for listening this talk on the online medium or YouTube as a YouTube video, and please start doing some preparation if you want to give the exam of this subject. And if you have any problem, so in any of my video or in presentation you will get my email ID, so you can directly write it to me. And for today, enjoy your rest of the day. Good night.